Hi, in this video, I will be showing you problem number 27 of chapter 13, section 1. Show that the curve with parametric equations x equal to t cosine of t, y equal to t sine t, and z equal to t lies on the cone z square equal to x square plus y square, and use this fact to help sketch the curve. So first we have to show this curve, the space curve given in parametric form, x equal to t cosine t, y equal to t sine t, z equal to t. When we combine x square and y square and add, and we get z square. So that will show z square equal to x square plus y square is what we get out of this parametric representation of the curve. So that is the first part of the problem. So let's say let's take x equal to t cosine t, y equal to t sine t, and z equal to t as given in the problem, and then we will try to show that x square plus y square equal to z square. So z is t. So now we are going to find out what x square plus y square is. So it is t square cosine square t plus t square sine square t. We can take the t square common factor. Inside the parenthesis it is cosine square t plus sine square t, which by Pythagorean identity equal to 1. So we get t square times 1, which is t square. So we get x square plus y square equal to t square, but we also know z is given to be t, so t square can be replaced by z square. So this gives us z square equal to x square plus y square, which is a cone directed towards the z-axis, with axis as the z-axis. So now let's sketch the graph. So now this, the parametric representation of the space curve is going to lie on the cone, which is directed towards the z-axis. We'll show that curve in the figure. We know that this is the cone, circular cone, because the base is x square plus y square. So let's graph the coordinate planes x, y, z, coordinate axis x, y, z, and then that will be negative z, negative y, negative x axis. Then we'll draw the cone. This is only a rough graph, so rough graph of the cone. So it is directed towards the z-axis. So the space curve is going to lie on this cone. So we graph that. It's going to kind of look like this. It's going in the anti-clockwise direction. So we are going to also show, maybe we can show a couple of points how we get this space curve. The vector function is a space curve on a cone in this case. So let's see how this curve is obtained by giving some values for t. Let's start up with t equal to 0. It will be x equal to t cosine t, y equal to t sine t, z equal to t. We have to substitute t equal to 0 there. Y equal to t sine t and z equal to t. If you substitute 0, x will become 0, y will become 0, z will become 0. It shows that 0, 0, 0, the origin, is a point on the curve. So surely it passes through the origin. Let's give another point t equal to pi by 2, other value for t. If we substitute that value of pi by 2 into this equation, parametric equation, we get x equal to 0, y equal to pi by 2, z equal to pi by 2 as well. So 0, pi by 2 is a point on the space curve. Maybe we can try a negative value for t. So t equal to negative pi by 2 will give us 0, x equal to 0, y equal to pi by 2, z equal to negative pi by 2. So 0, pi by 2, negative pi by 2 is a point on the curve. So you see 0, 0, 0 is a point on the graph, so which will be this one. It will be this point over here. And then we have 0, pi by 2, pi by 2. So on the x it moves 0, and then on the y it is pi by 2. And it's kind of behind pi by 2 and pi by 2. It's kind of behind, so it is going to be something like that. And then like that we can actually show every point. If you want to plot this one, 0, pi by 2, negative pi by 2, on the x it moves 0 units, on the y it moves pi by 2, and the z it moves negative pi by 2. It's kind of over there around that point. So we like that we can actually plot every point and then arrive at the space curve. Now we can also see how we actually get in a three-dimensional plot. This is the space curve. This is the final graph of the space curve, but we can also show that it is lying on the cone. So this tells us that the space curve r of t lies on the cone, which is directed towards the z-axis. Hope this video helps.